Hello, and welcome to the live broadcast of the Proton launch of the Anik G1 satellite for Telesat of Ottawa, Canada, a leading global commercial satellite operator and long-standing ILS customer. Anik G1 is our second launch in 2013, and will be our ninth launch with Telesat over the last 14 years. We are very pleased to serve Telesat on this important mission. This will be our 26th SSL satellite launched on Proton, and the 385th Proton launch overall since the initial flight in 1965. This is a special time indeed to have a launch with the Anik G1 satellite. 20 years ago, on April 15, 1993, the Lockheed, Khrunichev, and Energia International Joint Venture, the predecessor to ILS, was established for the commercial marketing of the Proton launch vehicle. I want to thank the collective mission teams of Telesat, SSL, Khrunichev, and ILS for their diligent work leading up to the launch. I would also like to extend my gratitude to those who work at the home offices and factories, all with the common goal of the success of this mission. So to our VIP group in Baikonur who will watch the launch live from the Proton Club, the teams at Telesat headquarters in Ottawa and at SSL in Palo Alto, California watching via satellite, and at the ILS facility in Western Virginia, thanks for tuning in to the ILS Proton launch of Anik G1.
You are looking live at the Anik G1 satellite, ready to launch aboard an ILS Proton from the Baikonur Cosmodrome in Baikonur, Kazakhstan. The launch of Anik G1 is a collaborative effort between ILS, International Launch Services, Khrunichev, Telesat, and satellite manufacturer SSL. Today's launch of Anik G1 is scheduled for liftoff at 12:36 a.m. April 16th at the Baikonur Cosmodrome, which is 2:36 p.m. April 15th here at the ILS Broadcast Center in Washington, D.C. Hello, I'm your host, Jennifer Gladstone. Thank you for joining us for today's launch of Anik G1 aboard an ILS Proton. It's been a while since my co-host has joined us here at the ILS Broadcast Center, but I welcome back Russ Prytula, ILS Program Director. Russ has worked on 14 launch campaigns from Baikonur, and this is his 12th time co-hosting launch broadcast. Russ, it is wonderful to have you back.
Thank you, Jennifer. I've been away from the studio for about a year and a half, and I'm glad to be back.
So take us through today's mission for us.
Gladly, Jennifer. Anik G1 is a commercial communications satellite built by SSL for Telesat. The multi-mission 55 transponder satellite will be located at 107.3 degrees west longitude. This satellite will double C and KU band capacity over South America from this orbital location, provide additional direct-to-home services in extended KU band, and provide military X-band coverage of the Americas and substantial portions of the Pacific Ocean. Let's take a look at the Anik G1 mission profile.
The following is the description of the geostationary transfer orbit mission flight profile of the ILS Proton launch vehicle with the Anik G1 communication satellite on board. The first 3 stages function to propel the orbital unit to a suborbital trajectory. The orbital unit consists of the Breeze M, payload adapter system, and the Anik G1 satellite. The sequence starts with the ignition of the powerful first stage engines that output 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from its launch pad, it immediately executes a roll maneuver to align its flight launch azimuth to 61.25 degrees in order to achieve a parking orbit inclination of 51.5 degrees as it travels eastward. The engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Then the first stage separation occurs. The second stage engines follow with nearly 540,000 pounds of thrust for 3.5 minutes. And then the third stage engine fires with 131,000 pounds of thrust for 4 minutes. The payload fairing is separated soon after third stage ignition high above the Earth's dense atmosphere. At stage 3 separation, the orbital unit has traveled from Baikonur to Russia near the eastern edge of Kazakhstan at 51.5 degrees north latitude and is moving about 7,300 meters per second, or 4.5 miles per second relative velocity. The upper stage of the ILS Proton rocket is called the Breeze M and is designed to inject payloads into a wide variety of target orbits. There are 5 Breeze M burns in this GTO mission design. The first Breeze M burn occurs about 2 minutes after the third stage separation, when the orbital unit is still in a suborbital trajectory. This burn will create a low Earth circular parking orbit with an altitude of 173 kilometers above the Earth. This 4.5-minute burn spans from Siberia to Russia's east coast. A half revolution later, the second Breeze M burn occurs to create the intermediate orbit. This burn centers the ascending node of the parking orbit, creating the first elliptical orbit and establishing the perigee location to be on the equatorial plane. This 17.8-minute burn spans from South Atlantic 800 miles east of Rio de Janeiro to northern Libya. 1 revolution later, the third and fourth Breeze M burns occur to create the transfer orbit. These 2 burns, separated by the jettisoning of the auxiliary propellant tank, greatly increase the apogee to closely match the geosynchronous altitude, making the orbit more elliptical and maintaining the equatorial plane perigee location. Both burns add up to 17.5 minutes and span from South Pacific 200 miles west of Santiago, Chile, to 300 miles west of Morocco. During the coast phases, the Breeze M performs attitude maneuvers in order for Anik G1's solar arrays to be exposed to the sun at a predetermined solar illumination angle, which is designed to satisfy its thermal and power requirements. During the 5th and final Breeze M burn, the orbital unit will perform a large plane change maneuver at apogee and the descending node from 49 degrees to 13.4 degrees inclination, and will increase its perigee altitude to just over 9,100 kilometers, maintaining the line of apsides on the equatorial plane in a 9-minute burn. About 12.5 minutes later, the Anik G1 satellite is separated from the Breeze M to reach its targeted geostationary transfer orbit. The total mission time from launch to Anik G1 spacecraft separation is approximately 9 hours and 13 minutes, and the total travel distance is approximately 4 times the circumference of the Earth.
Our broadcasts will conclude after the Breeze M first burn, about 16 minutes into the flight. But you can continue to follow the Anik G1 mission by visiting the ILS website. It's ilslaunch.com, by following us on Twitter, or by liking us on Facebook. Now here's some background information about today's launch. This will be the 385th Proton launch overall since Proton's first flight in 1965. This will be the second Proton launch of 2013. ILS launched the SatMex-8 satellite successfully on March 26th. The satellite operator for today's launch is Telesat, headquartered in Ottawa, Ontario, Canada. This will be the 9th Telesat satellite launched on an ILS Proton. The satellite manufacturer is SSL, based in Palo Alto, California. This will be the 26th SSL satellite launched on an ILS Proton. As it was mentioned, ILS partnership with Telesat dates back to 1999 with the launch of the Nimiq-1 satellite. The Nimiq-2 satellite was the first Proton M, Breeze M, launched in 2002. ILS Proton has launched on the entire Nimiq series, built Telesat. Dan Goldberg, President and CEO of Telesat, is on site at the Baikonur Cosmodrome for today's launch, and he sends us this message.
I'm Dan Goldberg, CEO of Telesat. Pleased to be in Baikonur for the launch of Anik G1. though I have to say it's a little bit windy and fairly cloudy right now, but we're hoping that everything clears up in about 8 hours when we launch Anik G1. Anik G1 is an important satellite for Telesat and our customers. For our customer Shaw, we're pleased to be adding 16 high-power Ku-band transponders so that they can expand their direct-to-home satellite services in Canada. For our customer Astrium Satellite Services, we'll be launching an X-band payload that will provide coverage of all of the Americas and a good part of the Pacific as well. And then our last payload is a payload for Latin America, really South America, where we'll be doubling our capacity at the 107 orbital slot. So we're excited about this satellite. We're excited about this launch. Go Proton, go Anik G1.
Now let's take a chronological look at Anik G1's journey to launch.
Typically, it takes about 2 years for the launch vehicle and satellite to be built, tested, and shipped to the launch site. From crew and spacecraft arrival, it can take from 4 to 7 weeks to complete a launch campaign. Today's launch campaign begins with the early team arrival in Baikonur. The spacecraft arrives aboard an Antonov cargo jet at Yubileyny Airfield. The spacecraft is offloaded from the plane and placed onto a railroad car. The thermally controlled rail car is hooked up to maintain the proper environmental conditions for the spacecraft during the 6-hour trip to the launch processing facilities. Once in the high bay, the spacecraft team does a series of systems tests and other standalone operations, including fueling the spacecraft. Fueling of the spacecraft is then completed. The satellite is then mated to the Breeze M upper stage and rotated horizontally to be encapsulated in the payload fairing in Hall 101. The spacecraft, fairing, and upper stage are now referred to as the ascent unit. The entire assembly is mated to the booster stages of the ILS Proton launch vehicle in Hall 111. The integrated launch vehicle is rolled to the Breeze M fueling station, where fueling of the Breeze M is completed. The complete rocket rolls out to Launch Pad 39, where the entire vehicle is turned up vertical from the railcar by large hydraulic erectors. Then the service tower is moved in to protect the vehicle. Proton rollout to the pad always occurs at exactly 6:30 in the morning, corresponding with the precise time the vehicle for Yuri Gagarin rolled out in 1961, marking this landmark anniversary in space advancement.
Larry Rubin, Senior Executive Director at SSL, sends this greeting, recorded earlier in Baikonur.
Greetings from the Baikonur Cosmodrome in Kazakhstan. It's a beautiful day today, if not a bit windy. We're looking forward to the Anik G1 launch today for Telesat. They've been a great customer. This will be the 4th launch for them in 5 years. I'd like to extend my thanks to Dave Wendling and Ken Skublix and Mike Minhaus and Errol Alder for the great cooperation that they've shown us throughout the program. I'd like to extend my thanks to ILS for the great launch campaign. It's been great working with them, great teamwork. And finally, I extend my thanks to all the folks at SSL. It takes over 1 million man-hours to build a satellite, and they've done a great job delivering this satellite on time. So go Anik G1, go Proton.
So Russ, how are the current weather conditions in Baikonur for the launch today?
The most recent weather readings of the Baikonur Cosmodrome indicate that we have mostly cloudy skies, liftoff temperature of 8 degrees Celsius, which equates to 46 degrees Fahrenheit. Ground winds are out of the north at 6 to 8 meters per second, and upper level winds are within their limits at all altitudes. So weather conditions are ideal, and currently we are go for launch.
Our next message comes from Dawn Harms, Vice President of Sales, Marketing, and Communications at ILS, recorded not long ago in Baikonur.
Greetings from Baikonur, where it's an absolutely beautiful day for the launch of Anik G1. I'm Dawn Harms, Vice President of Marketing, Communications, and Sales for ILS. I'm personally happy to be here as my first launch since joining the company. I'd like to take this opportunity to thank all the people who have worked so hard over the last 2.5 years, from ILS and Krunichev who manufacture the launch vehicle, the Proton launch vehicle, and SSL, the satellite manufacturer, and of course our customer Telesat, who entrusted us with the launch of the Anik G1 mission. Thank you. Spasiba.
We are now just under 6 minutes away from launch. Let's take a look now at the making of the Anik G1 satellite in the short video prepared by SSL.
SSL is the world's leading provider of commercial satellites, with more capacity on orbit than any other manufacturer. The company has a long legacy of trust and collaboration with Telesat, and Anik G1 is the 7th spacecraft that SSL has delivered to Telesat for its international fleet of geostationary satellites. The proven SSL 1300 modular platform is particularly well suited for satellites that serve multiple missions, such as Telesat's Anik G1, which is designed to provide direct-to-home television in Canada, as well as broadband, voice, data, and video services in South America, where economic growth has driven high demand for satellite services. The satellite will also provide government communications over the Americas and the Pacific. SSL's results-driven team designed the C, KU, X, and KA band payloads for Anik G1's orbital location at 107.3 degrees west longitude, where it will provide service throughout its 15-year mission life. Led by Executive Director Peter Graf, the program management and technical teams at SSL work closely with Telesat and suppliers from around the world to design, build, and test Anik G1. It takes a talented group of engineers, technicians, and managers with a passion for what they do and a drive for excellence to make a complex satellite such as Anik G1 a success. SSL would like to thank its customer Telesat for its ongoing confidence and support over the course of this satellite program. Thank you and congratulations to Telesat, ILS, and to the more than 3,000 employees at SSL who contributed to the success of Anik G1.
There are 2 minutes to go to the launch of Anik G1 aboard an ILS Proton. Now, as the ILS Proton travels easterly downrange, our viewers are going to notice some time lags in our reporting of some key milestones. The reason behind this delay is that as the ILS Proton follows its pre-planned flight path, it's going to pass out of range of the Baikonur reporting stations. At this point, signals are received by stations downrange and they are transmitted back to Baikonur. This does cause some brief delays in our reporting. And now we're going to turn it over to Russ, who is going to take us through liftoff of Anik G1.
Well, we have about a minute and a half left in the countdown. Today's launch of the Anik G1 satellite aboard an ILS Proton is a result of approximately 3 years of planning, mission integration, and mission design by many people on the various teams supporting this mission. Everyone on the Anik G1 launch team is awaiting the liftoff. The support teams are in their places in the launch bunker, control rooms, ground stations, and communications centers. And the final go for launch tolling we mentioned earlier is being completed now. In addition to those at the launch site, there are many others who have played an important role in the Anik G1 mission, including those at ILS Reston, Virginia, Khrushchev in Moscow, Telesat in Ottawa, Ontario, Canada, SSL in Palo Alto, California, and all others who have helped make today's launch of Anik G1 a reality. I might add that April 9th, just last week, marked the 17th anniversary of the first commercial Proton launch, which occurred in 1996. Just 30 seconds away from the liftoff at this point. We have a nice, beautiful picture this evening of the rocket on the pad. Again, we have some partly cloudy skies, so I'm not sure what our downrange view will look like, but looking good right now. Final countdown here, we have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And there it is, mission start. We have liftoff of an ILS Proton rocket from the Baikonur Cosmodrome in Kazakhstan with the Anik G1 satellite on board. About 10 seconds after liftoff, the rocket does a roll maneuver and will soon experience maximum dynamic pressure, also known as max Q, and is the maximum aerodynamic load in the vehicle. For Proton, it corresponds to about Mach 1.6 and occurs at 1 minute, 2 seconds after liftoff. When conditions are right, a condensation cloud forms around Proton as the vehicle passes through the sound barrier just prior to max Q, leaving an annular cloud in its wake that is visible when lighting permits. This is normal and is not smoke, but rather moisture from the atmosphere that condenses into tiny water droplets due to the aerodynamic shock wave created by Proton. Keep an eye on Proton and we'll see if we can observe the atmospheric reaction. We're 60 seconds into flight, everything's nominal. Still have a very good view there, so the cloud cover has not been an issue at this point as far as observing the rocket heading downrange. Everything seems to be proceeding nominally as the vehicle heads across the Cosmodrome in a northeasterly direction with a flight azimuth of approximately 62.1 degrees. We're coming up on the first stage's separation from the second stage that is set to occur at 2 minutes into the flight. Watch for the halo effect as the second stage engines ignite prior to the separation from the first stage. It looks like we saw it visually there. We'll just stand by for a confirmation. And we have confirmation of a good separation between the first and second stages. We have a signal of ignition on all 4 second stage engines. They will burn for a total of about 3 minutes and 27 seconds. The next key mission milestone will be stage 2-3 separation at L plus 5 minutes and 27 seconds. 20 seconds after that, the payload-faring pyros will fire, separating the two halves, and they will be jettisoned from the vehicle.
Thank you, Russ. Go Proton, go Breeze M, go Anik G1. You may have noticed 20 years as part of the ILS logo today. It's a special logo and a special and historic day for all of us at ILS. Here's a little bit on ILS's beginnings 20 years ago. On April 15, 1993, Lockheed entered the launch market with the establishment of Lockheed Khrushchev Energia International, or LKEI, the joint venture to exclusively market the Russian Proton launch vehicle. This event, 20 years ago to the day today, marks the beginning of what is now known as ILS. All Proton rockets are manufactured at Khrushchev State Research and Production Space Center in Moscow and then transported to Baikonur via rail car. Here's a brief look at some of the engineering behind the Proton launch vehicle. The total height of an ILS Proton is between 184 and 191 feet, around the same height as a 19-story building. Its gross liftoff weight can be around 705,000 kilograms, or 1,554,000 pounds, depending on payload and fuel weight. Proton's initial launch was on July 16, 1965, via the Proton 1 spacecraft. If we begin our in-depth look at the Proton in a manner chronologically consistent with the launch phases, we see that the first stage consists of a central tank containing the oxidizer tank, surrounded by 6 outboard fuel tanks. Each fuel tank also carries one of the 6 RD-276 engines that provide first stage power. Total first stage vacuum-rated level thrust is 11 meganewtons, or 2.5 million pounds of force. The second stage is a conventional cylindrical design and is powered by 3 RD-210 engines plus 1 RD-211 engine. It develops a vacuum thrust of 2.4 meganewtons, or 540,000 pounds of force. The third stage is powered by 1 RD-213 engine and develops thrust of 583 kilonewtons, or 131,000 pounds of force. It has a 4-nozzle Vernier engine that produces thrust of 31 kilonewtons, or 7,000 pounds of force. Guidance, navigation, and control of the Proton M during operation of the first 3 stages is carried out by a triple redundant closed-loop digital avionics system mounted in the Proton's third stage. The Breeze M upper stage is powered by 1 pump-fed, gimbaled main engine that develops thrust of 20 kilonewtons, or 4,500 pounds of force. It is composed of a central core and an auxiliary propellant tank, which is jettisoned in flight following depletion. The Breeze M control system includes an onboard computer, a 3-axis gyro-stabilized platform, and a navigation system. Finally, the payload fairing. It consists of 2 symmetrical payload fairing halves and a static envelope diameter up to 3.87 meters. There are multiple payload fairing designs presently qualified for flight, including standard commercial payload fairings developed specifically to meet the needs of ILS customers. The payload fairing for commercial launches aboard an ILS Proton separates at the nose cone in a planned maneuver, leaving the Breeze M and the spacecraft, together known as the orbital unit, to continue the journey to its planned orbit. And that is a brief look at the Proton and its stages.
Jennifer, at this point in the flight of Anik G1, the launch vehicle is currently in its parking orbit inclination of 51.5 degrees and is reported to be proceeding nominally. I have confirmation from Baikonur Cosmodrome Mission Control of a successful Stage 2-3 separation. I also have confirmation of a successful payload fairing separation.
The Anik G1 mission team consists of representatives from ILS, Telesat, Khrunichev, and SSL. Here with a greeting from Baikonur is ILS Program Director Mike Thie, recorded earlier at the Baikonur Cosmodrome.
Всем доброе утро. Slava Bogu сегодня пятница, which is Russian for good afternoon, everyone, and thank God it's Friday. My name is Michael Thie, and I'm Program Director for ILS, and we're here in Baikonur again for the launch of the next Telesat satellite, Anik G1. And first of all, it is a great Friday because we've completed Breeze M fueling. We rolled out on time to the launch pad. It's L-4, and as you can see behind me, the rocket is vertical and ready for launch operations. And everyone, as usual, has worked very hard to get us here today. Vladimir Bronfman and the Khrunichev team, our customer, Aero Alder, and the Telesat folks, and especially shout out to the spacecraft manufacturer, SSL, Peter Graff, Eric Geller, in particular Ben Randolph and the gang. Did a great job, and to Team Thie as well. And back home in Reston, to Tom Schutte. And this is my 4th campaign with all these same folks, and all I could say is let's do it again because we're getting pretty good at it. And I'd also like to say it's a great Friday here in Kazakhstan in Russia because 52 years ago today, Yuri Gagarin lifted off on his first manned space flight. And as we say out here, s prazdnikum, which is Russian for congratulations. It seems to be the word of the day. But an especially great Friday because my youngest son, Eric Nicholas Joseph Thie, turned 16 today back home. 16. I'm not sure who's getting old, me or him, but somehow he got to be 16. Happy birthday, Eric. I sure miss you, but I'll see you soon. So again, to everyone who's worked on the program here and at home, I send my thanks for your professionalism, your cooperation. It was, as always, a job well done. So Cindy, kids, Grammy, I will see you guys soon. Lee Money, this one's for you, pal. Спасибо большое. Стака, пожалуйста.
The launch site for ILS Proton missions is the Baikonur Cosmodrome. Let's take a closer look at the launch facility.
The Baikonur Cosmodrome in Kazakhstan is the oldest and largest operating space center in the world and was founded in 1955. It was originally built as a long-range missile center and later expanded to include launch facilities for space flight. It is located approximately 2,100 kilometers, or about 1,300 miles southeast of Moscow. The Cosmodrome itself is a large, wide-shaped complex that extends about 100 miles from east to west and roughly 55 miles north to south, which is about the size of Holland. The facility is operated by Roscosmos, the Russian space agency, and the area is under a long-term lease from the Republic of Kazakhstan. There are 3 pads available for Proton launches. Today's ILS Proton will launch from Pad 39 in Area 200, which is on the western end of the Cosmodrome.
So, Russ, where does the Anik G1 mission stand now?
Just seconds ago, I got confirmation of a nominal shutdown of the 3rd stage, as well as the separation of the 3rd stage from the orbital unit. So looking real good at this point.
Thank you, Russ. The Breeze M is a restartable upper stage for mission optimization and is compatible with all major commercial spacecraft platforms for dedicated single and multiple launches. The Breeze M can support dual-use satellites and satellites with hosted payloads, and even has demonstrated the capability to build and serve space stations. Let's learn more about Proton's Breeze M technology and its role in the Anik G1 mission.
We are coming up on Stage 3 separation from the Breeze M. The spacecraft, together with the adapter, separation system, and Breeze M, are called the orbital unit. At the moment of separation, the orbital unit will be traveling at about 7,300 meters per second, or more than 16,000 miles per hour. About 1.5 minutes later, the Breeze M will ignite for its first burn. That burn will last about 4.5 minutes. About 4 minutes after the end of this main engine cutoff, or MECO, the vehicle is scheduled to go out of range of our ground tracking stations. We will lose communications for about 70 minutes and then reacquire the signal again right after the second burn of the Breeze M.
Now here's a translated interview with Dr. Vladimir Bronfman, Krunichev Program Director for today's mission.
My name is Vladimir Bronfman. I am Anik G1 Program Director for the Khrushchev Space Center. Today is 12 April 2013, and our country celebrates the 52nd anniversary of Yuri Gagarin's spaceflight. This day is a great event for our country and for the whole mankind. It is of particular significance to those whose lives have been dedicated to space and Baikonur. I find it encouragingly symbolic that on this day the integrated launch vehicle with Anik G1 spacecraft has been rolled out to the launch pad, and the final preparation has commenced for the launch in the small hours of 16 April. We have been working on this launch for 2 years. In the meantime, our company has completed the design and analysis, produced the hardware, and conducted the tests with good results, conformant to international standards, as well as to the national standards of all parties involved in the program. Our customer for this launch is Telesat Canada, and a company that has been working with us for over 15 years. We have prepared 11 spacecraft launches for Telesat Canada. We highly appreciate the trust extended to us after last year when not exactly all the launches proved to be successful. We have jointly reviewed the causes of our failures. We came up with corrective actions, had them agreed upon with the customers' community, and implemented the actions, making every possible effort to enhance the reliability of Proton launches. We also attach great importance to our cooperation with SSL that entrusts us with their top-quality spacecraft. This is going to be our 26th joint launch, and we certainly immensely value our 20-year-long relationship with ILS. The upcoming launch will be 79th in our common history. The rocket is on pad, the tests are ongoing, and we will not spare our effort to launch on the due date.
So, Russ, you have an update on the status of the Anik G1 mission for us.
Yes, I have a report from Baikonur of a successful Breeze M main engine start. At this point, the orbital unit is still in a suborbital trajectory. This first of 5 burns will create a low Earth circular parking orbit with an altitude of 173 kilometers above the Earth. This 4.4-minute burn spans from Siberia to Russia's east coast.
SSL, the Anik G1 satellite manufacturer, is represented by Peter Graf, Anik G1 Program Director.
Good morning. My name is Peter Graf. I'm the Program Director for the Anik G1 spacecraft from Space Systems Loral. As you know, at this point, we've completed the integration of the Anik G1 spacecraft with the Proton launch vehicle, and it is currently erected behind me at Launch Pad 39. Overall, I'm very pleased with the Anik G1 launch campaign, and specifically all the cooperation, dedication, and professionalism of all the parties involved. Specifically, I'd like to thank the ILS team led by Mike Thie, the Krunichev team led by Dr. Vladimir Bronfman, the Telesat team led by Errol Alder, and I'd also like to recognize the key contributions from Eric Eller, the Space Systems Loral Launch Vehicle Mission Manager, and Ben Randolph, the Space Systems Loral Spacecraft Manager. We look forward to the Anik G1 launch on April 16th, Baikonur time, and the commencement of on-orbit operations of the Anik G1 spacecraft in early May. Thank you.
The Proton rocket is able to lift very heavy payloads into orbit. Proton launched Russian interplanetary missions to the Moon, Venus, Mars, and Halley's Comet. Proton also launched the Salyut space stations, the Mir core segment, and both the Zarya, meaning dawn, and Zvezda, meaning star, modules for today's International Space Station. Proton is a powerful rocket with the first stage engines producing 2.4 million pounds of thrust at sea level. Let's take a moment to learn more about the development of Proton. The Proton is a heritage launch vehicle with a long and significant history in space. Here are some quick facts. The Proton is the largest and most powerful Russian launch vehicle in operation. It has launched more than 380 times since the mid-1960s. Krunichev State Research and Production Space Center, the majority owner of ILS, is one of the pillars of the global aerospace industry and manufactures both the Proton rocket and the Breeze M upper stage. While the first Proton mission was in July of 1965, the first commercial Proton launch took place almost 30 years later in April of 1996 with the Astro 1F satellite for SES. The UR-500 vehicle's first 3 payloads were spacecraft called Proton 1, 2, and 3, and subsequently, the launcher was named after its original payload. Krunichev manages federal launch missions while ILS offers the Proton for commercial satellite launches. There are about 7 to 8 commercial missions a year and 3 to 5 federal missions per year, with 3 active launch pads from the Baikonur Cosmodrome in Kazakhstan.
I have confirmation of a successful Breeze M main engine cutoff, or MECO. MECO is a planned step in the mission, and the mission proceeds nominally at this point. In this geostationary transfer orbit insertion mission, we are at the point where the Breeze M upper stage is just getting started. There will be 4 more Breeze M burns before spacecraft separation, roughly 9 hours from now.
Satellite operator Telesat is represented by Errol Alder, manager of spacecraft programs.
My name is Errol Alder. I'm the Telesat Program Manager for the Anik G1 spacecraft, having recently assumed the position from my esteemed colleague Mike Minhas. The spacecraft behind me, encapsulated atop a Proton M Breeze M launch vehicle, is Telesat's latest acquisition to serve the growing need for satellite communications in North and South America. Anik G1 is the 5th spacecraft built by SSL for Telesat and will be launched from Launch Pad 39 at the Baikonur Cosmodrome in Kazakhstan by ILS and their partners. Anik G1 carries 5 distinct payloads, 16 Ku band channels with DTH Canadian coverage for an important repeat customer, Shore Direct, 12 Ku band and 24 C-band FSS channels serving South America, 3 X-band channels providing global coverage of the Americas, Pacific and part of the Atlantic for an important new customer, Paradigm, and 1 Ka band reverse DBS channel providing spot beam coverage in Canada. The spacecraft, weighing approximately 4,900 kilograms at launch and generating 12.7 kilowatts of power end of life, is expected to be in service for a minimum of 15 years. After the launch, the expectation is that Anik G1 will proceed through to operational services after completing transport orbit, maneuvers, in-orbit testing, and a drift to Anik's final location of 107.3 degrees west longitude. I would like to take this opportunity to commend SSL for producing a first-class spacecraft, with my thanks and appreciation going out to Peter Graf and the rest of the highly professional team at SSL. I'd also like to thank Vladimir Bronfman of Khrunichev and Michael Thie of ILS and their respective teams and partners for the dedication and professionalism in getting the Proton M Breeze M launch vehicle and launch pad facilities ready for launch. In addition, my thanks go out to my colleagues at Telesat who have contributed to the success of the program thus far. Last but not least, Ella and Maya, Daddy loves you, and I'll be home soon. Thank you.
Khrunichev State Research and Production Space Center is one of the cornerstones of the global space industry and is the majority shareholder in ILS. With more than 45,000 employees, Khrunichev's varied product lines serve the global satellite industry, as well as Russian, federal, and international space programs. Here's a little bit more now on Khrunichev.
Khrunichev State Research and Production Space Center has long been one of the most prominent space industry manufacturers in the world. Today, Khrunichev serves international satellite and space programs as well as Russian federal missions, working with 45 different companies in 22 countries across the globe. Khrunichev's diverse product lines include launch vehicles and launch vehicle upper stages, communication and Earth observation satellites, rocket engines, and space station modules. In 1993, Khrunichev joined forces with Lockheed Corporation and Energia in a joint venture to market Proton to the commercial satellite industry. In May of 2008, Khrunichev became the majority owner of that company, International Launch Services, or ILS. The merging of an American-based company with a Russian space industry giant was an historic first. The strategic consolidation that brought ILS into the Khrunichev fold also included bringing some of the largest Russian space manufacturers under the Khrunichev umbrella. The supply chain consolidation directly supports Khrunichev's most vital strategic asset, the Proton launch vehicle, as well as continued development of the next generation launch vehicle. Khrunichev's commitment to quality is exemplified in the phased improvements to the Proton launch vehicle. All upgrades have been 100% successful in flight. The phased improvements have increased Proton's lift capability to over 6 metric tons. And in 2011, ILS Proton launched its heaviest satellite, Viasat-1. The next phased upgrade will bring the total payload system's mass capability to 6.35 metric tons. And in direct response to operators' demand for lower costs to orbit for small to medium satellite launches, ILS and Khrunichev brought the ILS Proton Duo to the market. Using the full performance of the Proton rocket could reduce orbit-raising time from 6 months to 4 weeks for satellites with electric propulsion. Khrunichev has also invested in infrastructure upgrades, including a second spacecraft processing facility in Baikonur, in full use since 2011. Refurbishments to Launch Pad 39 are now complete, following the upgrades to Pad 24 last year. Khrunichev's commitment includes the development of the next generation of launch vehicles. The Angara launch vehicle system will include a light, medium, and heavy lift variant to cover the entire satellite mass spectrum. The Angara engines will utilize an environmentally friendly liquid oxygen kerosene mixture. Ongoing investment and improvements, our unified quality management system, and our commitment to mission success allows Khrunichev and ILS to provide significant value to customers, and a steady launch tempo provides a backdrop for a sustainable future serving the global space industry.
Confirmation of spacecraft separation is expected today around 11:49 p.m. on April 15th, U.S. Eastern Time, or 9:49 a.m. on April 16th in Baikonur. So, Russ, where does the Anik G1 mission proceed from there?
Well, Jennifer, following spacecraft separation, the spacecraft will then execute a series of planned operations over the next several days to include solar array deployment, reflector deployment, and engine burns as needed to drift the satellite into its orbital test slot. Following a period of in-orbit testing, the spacecraft will be moved into its operational slot of 107.3 degrees west longitude and begin to provide improved performance for Telesat's customers.
Remember, you can always keep current on the Anik G1 mission by visiting the ILS website, ilslaunch.com, by following us on Twitter, or by liking us on Facebook. Also at ilslaunch.com, you can check out pictures of past ILS Proton launches as well as the current mission, read blog posts from the ILS mission team, and learn more about ILS and its missions. The next ILS Proton launch is Eutelsat 3D, scheduled for mid-May. I'd like to thank my co-host, Russ Prytula, Program Director at ILS, for his assistance and mission updates today. Russ, it has been great having you back.
It's been a real pleasure, Jennifer. Great to be back in the broadcast world.
And this concludes our live coverage of the ILS Proton Breeze M vehicle launch of Anik G1. On behalf of the ILS team and our partners and customers worldwide, I'm Jennifer Gladstone. Thank you for watching.